Design rule checking, in other words DRC, plays a critical role for MEMS verification in edit. It ensures the layout adheres to manufacturing guidelines and identifies design defects. To perform an effective DRC, it is necessary to set up complex rules that meet the design requirement. This video will demonstrate how to define and execute these DRC rules, allowing you to confidently verify your MEMS design. For this MEMS verification demonstration, we'll use a magnetic actuator design as an example. DRC can be accessed through the verification toolbar in edit. Setting up DRC rules is straightforward and provides an efficient method to run advanced rules. For example, let's set up a spacing rule. Begin by editing the DRC standard rule set, then click Add in the rules list. The rules can be modified with various options, including rule types, distances, and layers. For instance, a spacing rule can be created to produce an error if the distance between the permalloy layer and the silicon structure layer is less than 8 microns. Ensure the rule is enabled so it can take effect during the verification process. Additionally, edit can perform geometry checks, such as flagging polygons with more than 199 vertices to enhance the overall design quality. Now that the rules and geometry flags are configured, the DRC can be run to verify the design. Errors detected during the DRC are displayed in the verification navigator, which simplifies the debugging process. As seen, the verification navigator highlights errors caused by the spacing rule and geometry flag that was set up earlier. For example, let's debug the spacing error. Expand the spacing error section in the navigator to see the cell name, where the error occurred, and the number of errors. Clicking on the cell, for example the magnetic actuator, highlights all the error location within that cell. The error locations are circled along with coordinate lines, helping you visualize where the errors occur. In this example, 2 errors are aligned and parallel. Expanding the cell where the error occurred will show the error number, and clicking on it will show the exact location of the error. To resolve this error, increase the spacing between the 2 layers at the highlighted location. Now, rerun the DRC. The errors in the magnetic actuator cell are resolved as they have disappeared from the verification navigator. Another useful feature is the DRC box option, which limits the DRC check to a specific area of the layout. This can save time by focusing the checks on a smaller region, speeding up the process, and making debugging simpler. For example, running the DRC on the bottom left corner of the layout checks only that area, reducing the number of errors detected. DRC ensures the MEMS design meets manufacturing standards. Setting up a design rule is important to optimize your design, and tools like Verification Navigator make resolving errors easier. Check the cards appearing on this video for related application notes, and learning resources for MEMS designs are available from EDA Solutions Support Hub portal.